We're going to tackle a limit today that has two variables in it, an x and a y. We're going to try and figure out if this limit exists, and if it doesn't exist, we're going to show why. So let's get into it. First thing that we're going to do is we're going to write out our function. We're going to call it 6x cubed times y divided by 2x to the fourth plus y to the fourth. So that's our function in two variables, right? And that's what we're going to be working with. So we want to know if the function exists, if there's a limit as it goes to 0, 0. So one of the things that we can do is we know our function has to go to 0 from every which way we're coming at it in our 3D picture. So let's assume we are on the line. We're going to fix our y value at 0, and we're going to let x vary at this point. And then we're going to bring x to 0 and see what happens. So let's start off with plugging in a 0 everywhere we see a y. So 2x to the fourth plus 0 to the fourth. So this is going to give us a 0 on the numerator. So this is going to give us a 0 as our function. And of course, we see that that function is going to go to 0 as x goes to 0. So we know that is going to go to 0, and we have no problem with it whatsoever so far. Next thing that we're going to do is, again, we're going to focus on this second variable, our y. We're going to switch it to something else, and we're going to come at our 0, 0, our origin point of our function, from a slightly different place. In this case, our second one, we're actually going to say, let's come in along the line x, x. So we're going to punch in everywhere we saw a y. We're going to turn it into an x. And notice on our numerator, this gives us 6x to the fourth. Our denominator ends up being, whoops, that shouldn't be a 2, 3 copies of x to the fourth. Our x to the fourth is going to cancel, and we get 6 divided by 3, which is equal to 2. So if we are at our function where the same number we're working with as our x as our y, then that is going to give us a z value, or an output of 2, which of course is going to go to the number 2 as x goes to 0. So now we have our function going to two different places depending on how we approach 0, 0, which tells us that the limit does not exist. And we're just going to use a DNE for does not exist. Also, as a side note, the 3 dots that you see there in a triangle, that's the symbol for therefore. Thank you for listening.